Good evening, chemists. Welcome to today's episode of Homemade Science with your host, Vivien Sue. Today's episode is generously sponsored by Miss Carrie. Thank you, Miss Carrie. Today, we're going to be doing some ice fishing. So what are we waiting for?
What you gonna do?
So I'm going to do some ice fishing. So essentially what I'm going to do is I'm going to pick up some of these ice cubes with just a piece of string.
How's that gonna work? That's literally impossible.
Well, I'll show you. So for this experiment, we need some ice cubes, liquid water, salt in this case, our first trial, and 2 feet of string. So my dependent variables, or what I'm choosing to stay the same, is the ice cubes, the liquid water, the amount of solute I'm going to spray on the ice cubes, which in this case will be 10 pinches of each solute, and the length of my string, which in all of the trials will be 2 feet. Alright, so as you can see right now, as I pour in the water, I can't lift it at all. But what I'm going to do is I'm going to spray some salt. So, I first have to lay the string across the ice cubes. Now I'm going to sprinkle in 10 pinches of salt. Yeah!
How long did it take?
It took around 2 minutes and 18 seconds, but probably a little less than that. But that's our time for salt, and let's move on to sugar, the next trial. Can sugar be
Now let's get into the chemistry behind this demonstration. Before the salt is sprayed, the ice cubes have a very rigid structure, as shown in the diagram. The ice cube is a solid, and solids are held by strong energy bonds between particles and extremely sturdy molecular structures. The hydrogen and oxygen molecules of the water are inseparable. Think about them as this mama panda bear and this baby panda bear. However, once I add in the salt will disperse into sodium and chlorine ions. The ions will separate the water molecules, making it harder for the ice cube to retain its rigid structure. This makes it harder for the ice cube to remain in its solid state, as shown in this diagram. Think about these ions as these minions and cute little Agnes. The minions and Agnes get in the way of the mama panda bear and her baby. Since it's harder for the ice cube to remain a solid, the salt ions actually lower the freezing point of the ice cubes. The ice cubes will no longer freeze at 0 degrees Celsius. It will freeze at a much lower temperature. When the ice cubes first come out, they start at a temperature of around 0 degrees Celsius. But the salt ions will make it so that the ice cube can't freeze at this temperature anymore. Instead, they actually melt at this temperature. As the tops of the ice cubes are melting, some of the surrounding water in the glass will float to the top. This water contacts the coldness of the ice cubes, which slows down the liquid particles, making this water freeze. Now the string is caught in the middle of the ice cube, allowing me to lift up the ice cube with the string.
Now I'm going to start trial 2. Everything is the same. The only thing that's different this time is that I'm going to be using sugar instead of salt. Alright, here we go.
Of the second trial, it was clear that salt was a much better solute. It took around 8 minutes for the string to attach just slightly to the ice cube with sugar. So clearly salt is the winner.
Similar to the original trial, the sugar does something very similar to the ice cubes. At the start of the trial, the ice cubes are in their rigid form. So again, we have our happy mama panda bear and her baby. However, once the sugar is introduced, that structure will be interfered with. The sugar molecules make it harder for the water to retain its rigid structure and stay in its solid form, as shown in the diagram. Like in the first trial, this means that the water molecules would have to be slowed down for the ice cubes to remain in their solid form, hence the lowered freezing point. However, the sugar does not dissolve into ions like the salt compound. The sugar dissolves into molecules because it is a molecular compound. Ions come with much more particles than molecules do, so although the sugar does interfere with the water's molecular structure, it doesn't cause as big of an interference. This means that the sugar does not lower the water's freezing point as low as the salt does. Let's say that Agnes decided to get an ice cream treat with her sisters, Margot and Edith, so she wasn't here to bother the mama and baby panda. That left only the two minions, and without Agnes, they did not cause as big of an impact. If we assume that the ice cubes have a temperature of around 0 degrees Celsius when they first come out, we can in fact say that this 0 degrees Celsius is not that far away from the new freezing point, since the sugar molecules do not affect the ice cube's molecular structure greatly. Therefore, the ice cubes will melt at a slower rate. After all, the temperature is near enough the freezing point such that the particles are barely moving with enough speed such that the ice cubes are melting, but very slowly. In the first trial, however, the difference between the current temperature of the ice cubes and the lowered freezing point was much greater, which meant faster melting rates. This accounts for why it took me a longer amount of time to lift the ice cube.
This is the start of the third trial. Again, everything is the same. The only thing that I'm changing is the solute that I'm using. The third trial, we will use starch. All right, here we go. We are fast approaching 17 minutes now, and I still cannot lift any of the ice cubes with the string. Therefore, I can definitively say that starch will not allow me to lift the ice cubes with a string.
In the final trial with starch, I wasn't able to lift any of the ice cubes with the string because starch is insoluble in water. This means that starch does not interact with water at all. This lack of interaction means that the ice cube structures will not be tampered with, so they will retain their solid form. This means that there's no lowering of freezing points. Everything remains exactly the same, so we're back to square one, when it was impossible for me to lift the ice cubes with a string. There will be no melting or freezing that will allow my string to be stuck in the middle of the starch, which in this case is our minion Bob, who just lingers there. He doesn't interact with them at all, and this is why I wasn't able to lift the ice cubes with my string. So that is it for today's episode. Thank you so much for joining us, and I hope you enjoyed it and learned something. Till next time.